Alright, next we're going to take a look at logarithmic differentiation. So just a reminder of our laws of natural logs. These are just our properties. Here, if you have the product of the natural log of a product, you can rewrite using addition. If you have a quotient, rewrite using subtraction. You have your power rule. And then, same as we had steps before, we're going to have guidelines for logarithmic, and these are just some short, quick hit steps for you to look at. This is just the rules for the derivative of natural logs, which we covered previously. So taking the derivative of a natural log, the derivative of a natural log. Okay, so we have a natural log problem. The first thing we want to do, if we can, is to rewrite algebraically. So we want to break this apart. This is multiplication, so we can break those apart using addition. So let's just rewrite first of all. So the natural log of 3 plus we have the natural log of t plus the natural log of e to the negative t. Alright, can I go ahead and use this as well? So one more step, let's use that power rule. So natural log of 3, you can do these all at one time next time if you'd like, but minus t natural log of e. Alright, let's go ahead and take the derivative of this. So we'll have, we're going to evaluate y prime. What's the natural log of 3? The derivative of the natural log of 3? Just 0. The derivative of the natural log of t is just 1 over t. What is the natural log of e? Recall, natural log of e is equal to 1. So that's just negative t times 1. So we're just going to have minus t. So y prime is going to be 1 minus t over t. Oh no. We'll just have 1 over t minus t. Okay, we have y equals the natural log of e to the theta over 1 plus e to the theta. So first of all, algebraically, let's rewrite this using division. So we'll have natural log of e to the theta minus the natural log of 1 plus e to the theta. Using our properties here, what would we get? Theta natural log of e. So still using properties, so we have theta times the natural log of e is equal to, and then over here we just have this. What's this term simplify to? Just theta, because that's 1, so we're just going to have y is equal to theta minus our term on the right. Okay, now let's take the derivative d theta on each side. So we're just going to have y prime is equal to, what's the derivative of theta? That's like 1 theta. Theta is like an x, a variable. Just 1. Alright, then we have the derivative of this natural log. So remember, so it's 1 over what's in our parenthesis, e to the theta times d theta of the inside function as well. So, okay, so bringing that down, we have our 1 minus, what's the derivative of 1? 0. What's the derivative of e to the theta? Just e to the theta, so I'm just going to have this term times e to the theta. So that's just going to be e to the theta over that denominator. Okay. This is one solution. If I wanted to combine these terms and get them over a common denominator, I could. I'll just let you see that answer. It's just going to be, so this is one of the solutions, or if I got a common denominator, it would be 1 over 1 plus e to the theta. Because, so if I put, let me just show you that step. e to the theta. That's going to be my common denominator. This term doesn't have it, so that would give me 1 plus e to the theta. This term is already over my denominator, so I just have minus e to the theta. Now you can see that these two cancel, and we're just going to be left with 1 over 1 plus e to the theta. So these are equivalent forms. Make sure you're able to get to both. Alright, the first thing I want you to do with this is algebraically simplify and use properties of logarithms as much as possible before you start taking the derivative. Okay, so we're now here just using all the properties. Now we're going to take the derivative. So I'm just going to bring this out. So just practicing the derivative of these natural log functions right now. You're going to have the derivative of the natural log of this is just going to be 1 over 6x minus 1 times the derivative of this inside. What's the derivative of this inside? Just 6. Good. Then over here, bring down the 3. The derivative of the natural log of 1 over 4x plus 5 times the derivative of the inside function, which is 4. Okay, we can simplify all that. Here and here reduces. So that would leave me with a 3 over 6x minus 1. And I would just get a 12 over 4x plus 5. So that's our first derivative. If you got a common denominator for that, got a common denominator of these two and multiplied it out, you may see it in the form 84x plus 3 over 6x minus 1 times 4x plus 5. If you want to check that on the side, you can. Okay, so what we've done, we've just practiced using our properties and rules in this top part and then taking the derivative. The next thing we're going to look at is logarithmic differentiation. So let's look at, we'll start with number 4 here. Okay, so the directions specifically tell us to use implicit differentiation to find y. Okay, the first thing I want to do is rewrite this using my properties. Okay, next in my guidelines, if you look back to your page that you copied your guidelines on, it says take the natural log or differentiate everything d dx of each of these terms. So take the derivative of each of these terms. Okay, so what do we get when we get the derivative of y squared? 2y dy dx. Good. And what's the natural log derivative of natural log of x? Just 1 over x. Natural log of y is just 1 over y, but we also have dy dx. And derivative of that term is just -4. Derivative to the right is just 3. So our next step is to get all our dy dx terms together. So I'm going to group these two and factor out a dy dx. And I'm going to move this term to the right. Okay, so then we divided both sides by this parenthesis, and we're left here. Now when I simplified this, I got a common denominator in the numerator, which is of an x, so this is a combined fraction. I did the same thing in here so that we can simplify this a little bit better. So if I multiply by the reciprocal here, y over 2y squared minus 1, whatever you do there, do in the numerator as well, y over 2y squared minus 1. Okay, so these would just simplify here, multiplying by that common factor, and then we would just have y times 4x minus 1 over x 2y squared minus 1.